welcome to class. This is Mrs. Brunk. We are starting day 2 of our unit on exponents, and today we're going to be looking at the different multiplication properties of exponents. And we're actually going to start off the lesson today, like we'll start off a lot of the lessons, with a warm-up, and this is really to evaluate and activate your prior knowledge. So I'd like for you to take a moment and pause the video and work on the warm-up in your study guide, and we'll kind of reconvene in a second. Okay, so let's take a look at the warm-up. There were two different sections. The first one, I asked that you would write each expression using an exponent. So the first one obviously is written without an exponent, just as repeated multiplication. And so since there are 4 x's being multiplied, that's equivalent to x to the 4th power. In number 2, the first thing we wanted to do is go ahead and multiply the 4 times the 4 on the denominator to get 1/16. And a way that we can write that with an exponent, remember, is by using a negative exponent. That would be the same as saying 16 to the negative 1. In the second section of the warm-up, we're asked to write each expression without using an exponent. So we're kind of going in the reverse direction. So writing 4 to the 3rd without an exponent would be 4 times 4 times 4, which is 64. And then finally, with number 5, that actually should be number 4, and the other one should have been 3. The numbering's off. But y squared, the only way we could really write that without an exponent, since we can't get a final answer because we don't know what y is equivalent to, we can just write it as y times y. So what are our learning goals today? What is our focus of all of the concepts that we're going to be studying today? This kind of encompasses the entire lesson, using multiplication properties of exponents to evaluate and simplify expressions. So that's what we're going to be doing. And the first one we're going to look at is actually called the product of powers property. And so what the product of powers property says is that the product of 2 powers with the same base, so they must have the same base, and we're multiplying, which is what product means, equals that base raised, so it's that same base, raised to the sum of the exponents. So in other words, when you multiply 2 bases that are the same, you add the exponents. So a numeric example of that would be here. 6 to the 7th power times 6 to the 4th. Notice the bases are both 6. So to simplify that as an exponent, we can simply add the exponents, 7 and 4, as we did here. We added them. Okay. And we get a final answer of 6 to the 11th power, which is quite a large number, so leaving it as 6 to the 11th power is fine for now. It is a very large number. We'd probably have to write in scientific notation. In general, algebraic statement of this property looks like this. A to the m power times a to the n power is equal to the a to the m plus n power. In other words, add the exponents. So this example up here, 3 to the 5th times 3 to the 2nd, really does demonstrate why this is true. The 3 to the 5th power really means multiply 3 by itself 5 times. The 3 squared really means multiply 3 by itself twice. And then now we have an expression then that is actually multiplying 3 7 different times. So that's the same as saying 3 to the 7th power. Okay, so let's look at some applications of this property, the product of powers property. We're going to look at a few together, and then I'll have you try a few on your own. So we're going to take a look at example A. And example A says to simplify 3 to the 2nd times 3 to the 5th, which, written as an exponent, we could say was 3 to the 7th power, because we're adding the exponents. And then 3 to the 7th, if we wanted to evaluate using our calculator, and type that in, we'd get 2,187. So if you can get a number that doesn't have to be written in scientific notation, then you want to go ahead, and simplifying would be to not only write it as a simplified exponent, but then as your final answer of something like 2,187. If it's a really large number that you have to write in scientific notation, you're okay just leaving it as an exponent. Okay, so here's a little more complicated example. This time we have two actually different bases. We have three terms that have a base of 2 and one that has a base of 3. Well, we said in the property that you can only use this if you have the same base. So we could go ahead and put these bases, oops, I'm sorry, I guess I looked at that wrong. There's 2 that are 2 and there's 2 that are 3. So to put the 2's together, we add the exponents. So when we add the exponents 4 and a negative 2, they add up to 2. So that's 2 squared. And then when we put the 3's together, that's 3 to the 4th times 3 to the 2nd, which would be 3 to the 6th. So that leaves us with 3 squared times 3 to the 6th power. And I'm going to check that real quick to see that might be a large number. Actually, it wasn't so bad, just 2,916. So we'll go ahead and leave that as our final answer. Now here's one that's just only involving variables, and so we can use the same properties whether they're variables or numbers. And so again, you have to match up the bases that are the same. So I have a q to the 3rd and a q to the 6th, which can be written then as q to the 9th power because 3 plus 6 is 9, and then times r squared. And in this case, because we don't know what q's value is or r's value, there's really nothing more than we can do here than just leave it as q to the 9th times r to the 2nd power. And typically we'll put the variables in alphabetical order. Now moving on to example D, notice now we're kind of mixing in some negative exponents, and I always want to encourage you to try to simplify by using this property first and combining any of the bases together that you can, because as you'll see in this case, we have 3 bases of n. One's raised to the 3rd, one's raised to the negative 4th, and one's raised to the 1st. And when we put them all together, instead of dealing with that negative exponent, and I add the 3 exponents together, the 3, the negative 4, and the 1, they add up to 0. And remember, the 0 exponent property says anything except for 0 raised to the 0 power is 1. So that's our final answer. Now what I'd like you to do is go ahead and do the next 4 as a U try. And I want you to pause the video and try those and check your answers. Okay, let's go ahead and check your work. In this first example, 7 to the 12th is the answer, and of course that was a very big number, something we'd have to write in scientific notation, so it's okay to leave it as 7 to the 12th. So your correct answer there is 7 to the 12th. Example F, I was able to combine the 2 bases of 5 together to get 5 to the 10th, the 2 bases of 3 together to get 3 to the 1st, and then when I multiplied them all together, I got not too large a number, 29,296,875. So our final answer there is that. In G, a common mistake, by the way, is when there is no exponent listed on a variable. If it helps you out to just go ahead and put a 1 there, that's what I do, just to remind me that there is a 1 there. So when I combined the m's together, I ended up with m to the 5th power. Went ahead and took the n with the negative exponent and rewrote it as the reciprocal, so 1 over n to the 4th. And then when I multiply them together, which m to the 5th is really m to the 5th over 1, when I multiplied, I had m to the 5th over n to the 4th, and that's my final answer, as simplified as I can get. Finally, with H, all of the bases are x. There's an x to the 1st, an x to the negative 1, an x to the negative 3, and an x to the negative 4, which adds up to x to the negative 7. And then to get rid of the negative exponent, we just took the reciprocal. Okay, so notice in your notes this reminder that I just talked about, that a number or variable written without an exponent, so if it doesn't have an exponent, it really means that the exponent is 1. It's sort of implied. Okay, so let's move on to our second property of the day. This time we're going to be looking at the power of a power property. You can see that we have a lot of P's today. So power of a power property says this: a power that is raised to another power. So we have a power raised to a power. Here's an example of that. 4 to the 3rd, then that whole thing raised to the 2nd. That equals the base raised to the product of the exponents. In other words, when you raise a power to a power, you multiply. Raising a power to a power, you multiply. There's an example with numbers. 6 to the 7th raised to the 4th would actually be the same as saying 6 to the 7 times 4, or 6 to the 28th power. And that works as well with variables. So if I had something like a to the m, then raised to the n power, I would be able to simplify that by writing that as a to the m times n power. So again, the basic property is when you have a single base that's raised to two different powers, when you raise a power to a power, you always are going to multiply. So let's go ahead and look at a few examples. And again, we're going to try a few together, and then I'll have you try a few independently. So this first example shows a base of 5 that is squared initially, but then it's being raised to the 4th power. So what that really means, and I guess maybe to take a step back and show you why this property works, is this really means 5 squared times 5 squared times 5 squared times 5 squared. And so then it all comes back to that power of a product property. See, now we have 5 bases that are all the same. They're all 5, and they're each being raised to the 2nd power. So if we were to then add these exponents, the 2 plus 2 plus 2 plus 2, that's 5 to the 8th power, which is really the same thing as just multiplying the 2 and the 4 together, multiplying them. So our final answer would be 5 to the 8th power. Now in example B, notice that we have 4 being raised to the 3rd, but then it's being raised to the 0 power. And remember, anything except for 0 that's raised to the 0 power will always be 1. So there's really no sense in even worrying about raising 4 to the 3rd and then raising that to the 0 power, because anything that's raised to the 0 will always be 1. Okay. Now example C, that's a little trickier, because now we have an x being raised to the 3rd, and that's being raised to the negative 5th power. And then we have another base of x that's being raised to the 4th. So my suggestion here would be to simplify this piece first. So this makes this x to the negative 15th power. Now we can use our product property that we learned the very first lesson, or part of the lesson. And when we have two bases that are the same, we add the exponents. So when I add a negative 15 and a positive 9, that gives me an x to the negative 11th power. And of course, we don't want to leave a negative exponent in our final answer, so we can use that negative exponent property to rewrite this as 1 over x to the positive 11 power. So there we go. So what I'd like to have you do then is try the next 3 as you try examples, and check back in for your answers. So pause the video now, try example D, E, and F. Okay, so go ahead and check your answers for example D, E, and F. And if you had any issues with any of them, be sure to write that down as you complete the WISC assignment after the video. Okay, so we're going to move on to our final property of the day. Our final property, of course, has a bunch of p's again in it, but this time is called the power of a product property. So we had power of a product of powers, we had a power of a power, and this time it's power of a product property. And this property actually arises when you have a product, so in other words, 2 or more things being multiplied, and you're raising the entire product to a power. So here's what the property says. It says a product that is raised to a power equals the product of each factor raised to that power. So in other words, that each thing in the product must have the exponent applied to it. So here's an example of that. We have 2 times 4. Notice they're in parentheses being multiplied. So that groups them together, and that means that, as we talked about in the prior lesson, that whatever comes directly before the exponent applies to. So in this case, the parentheses says this whole thing goes with that exponent. So that means I have 2 to the 3rd. And I also have 4 to the 3rd. So when I combine them together then, the 2 to the 3rd is 8, the 4 to the 3rd is 64. I can then multiply those together to get 5 to the 12th power. And that, again, that property applies to variables as well. So something like this, AB, the product of A and B raised to the nth power, would be A to the n. Oops, I put a little bit too much highlighter on that. A to the n times B to the n. And let's take a look at an example. So 8x being raised to the third power is the same as saying 8x times 8x times 8x, oops, which really is, if we took the 8s and multiplied them all, is 8 times 8 times 8, or 8 to the third power. And if we took the x's and we multiplied them, that's x times x times x, which then is x to the third. So that would give me 8 to the third, which is 512, and then x to the third. Okay, so flip the page and let's take a look at example 4a. And one thing we want to always be careful about is negatives and parentheses and exponents. Anytime those come together, you know, there can be some things that are tricky there. And so I'd like to take a look at these two examples with you. Example A, which says we have a negative out in front. We have 2y grouped in parentheses and then the squared. So what exactly does that exponent go to? Well, the exponent goes to what's directly in front of it. And in this case, because there's parentheses, it means it goes to everything in the parentheses. So the 2 actually goes to the y, and it goes to the 2. So we actually have 2 squared, and we have y squared. And then that negative out in front just acts as a way of saying take the opposite of. So it's independent of the exponent. So we have the negative out in front, the 2 squared is 4, and then the y squared. Now with this one, notice that the negative is inside the parentheses. And what that really means is what's being raised to the third power is both negative 2 and y. So this really means negative 2 cubed and y cubed. And negative 2 raised to the third power, that would be multiplying a negative 2 by itself 3 times. A negative times a negative times a negative would be a negative. So that's a negative 8 y cubed. So I'm going to go ahead and try example 4b, part A and part B as a U-try, and check back in. So pause the video now, try example A and B from example 4b, and turn back in to check your answers. Okay, go ahead and check your work, and again, be sure to make a note of any of the examples in the guided notes that you have difficulty with, and make sure you ask about them in our next class. Okay, so for our final example together today, we're going to do example C together, and then I'm going to have you try D as a U-try to end the class. So we're going to be mixing a lot of the properties that we've learned so far together in these examples, so they're a little more complicated. But again, if you just remember, first of all, it doesn't matter what order you apply the properties in. There's not some set order of operations like we have with number operations. Exponents can be properties can be applied in any order. But just make sure that you always keep in mind the properties that we've learned. So in this case, I have a product, x to the 6 times y to the negative 3 power. If you want to go ahead and take care of the issue here with this negative 3, that's as an exponent, that's fine. But what I do is I'll go ahead and apply the power of 2 to both of these. So this really means x to the 6th squared times y to the negative 3 squared. Now I'm going to be using the power of a power product property, which says that when you raise a power to a power, you multiply. So this really is equivalent to x to the 12th power. And this is really equivalent to y to the negative 6th power. And now at the end, I'm going to take care of that negative exponent. And I can do that by taking the reciprocal. So this really means x to the 12th times 1 over y to the 6th, or you can go straight to, just putting it on the bottom, and so your x to the 12th would be on the top, and now your y to the positive 6 is on the bottom, and that's your final answer. So go ahead and pause the video and try example D and check back in for your answer. Okay, go ahead and check your work on that final U-try example. 1 over y to the 4th should be the final answer. And if you could do that one, you're in really good shape for tomorrow. Now, I want you to go ahead and note And again, any issues that you might have had, anything you were struggling with, any properties that you didn't quite grasp. And of course, we'll be sure to spend some time on that tomorrow. But make sure that you indicate those things as you work through the summary and writing your question. So make sure you complete your WISC, and I'll see you in class next time.